Hi everyone and welcome to the second section of the title, GraphQL Schema for a Blog. In this section, we will take a look at the basics of GraphQL Schema and types required for a blog. Later, we'll explore the features of a very powerful GraphQL developer tool called GraphQL. Lastly, we will discuss how Relay is opinionated about the GraphQL backend and what changes do we need to make the GraphQL backend Relay compliant. Schema and types required for a blog. In this video, we are going to take a look at the foundation of GraphQL backend by taking a look at schema and type system of GraphQL. Then we'll move on to discuss the base of the schema that we'll require to build the blog. Then we'll write some code to materialize our schema. GraphQL schema is composed of special root types like query and mutation. Further, queries and mutations are composed of GraphQL object types, which are in turn composed of GraphQL scalar types. The scalar types represent the leaves of the query tree and resolve to actual concrete data. GraphQL comes with a set of scalar types out of the box, namely int, float, string, boolean, id, but we can also create our own scalar types. The id scalar type represents a unique identifier, often used to refetch an object or as the key of a cache. The id type is serialized in the same way as a string. However, defining it as an id signifies that it is not intended to be human readable. Now let's build a very basic GraphQL server for the following schema, composed of query and mutation type, which in turn rely on the post type. In addition to the setup environment, we'll now install the GraphQL package and the Mongoose package. Now let's dive into the code editor. Let's start building the backend. So here in the first three lines, we are including the required libraries, namely Express, Express GraphQL, and GraphQL. In these three lines, we are implementing the GraphQL types that we are yet to implement. So these files do not exist yet, but we'll implement them, and I have already created empty files for them with this respective directory structure. Moving on, we have used the GraphQL schema type that we have imported from the GraphQL package to build our schema. You can see that we are giving it query and mutation type that we are yet to define. We'll do that now. In the next line, we are creating an Express application. Post that, we are telling the Express application to use the GraphQL middleware. Lastly, we are running the Express application on the 5000 port. Now we can go on and implement these files, but before that we need to implement our model for data access. So let's go ahead and do that. I've already created a file in which our model will reside. We will be using MongoDB with Mongoose connector to build our backend. Here in the first line, we are requiring the Mongoose library. In the second line, we're using promise with Mongoose. In the next line, we're using the connect command to connect to MongoDB on localhost and talk to this database, blog minus GraphQL. Then we import Mongoose schema and create a schema for our blog. Post that, we use the model function from Mongoose and create a model for our blog. Post that, we create three functions using the model that we will use in our application. Let's explore them one by one. In the get posts function, we're using the post model find command to get all the posts. In the get post function, we're using the post model find one function to get a post by its ID. Lastly, in create post, we are taking a post as an argument and we are using the save command from Mongoose to save it to MongoDB. Now that our model is ready, we can go on and start implementing the types. Let us start with the post type. Here in the first line, we are including GraphQL object type not null, string, and ID from GraphQL package. We can see that post type is nothing but a GraphQL object type that has a name, description, and fields. The fields that we are using in this blog for now are ID, title and content. Each field is composed of a type, description and resolve function. So for ID, the type is a non-nullable GraphQL ID. It has a description and the resolve function gets the ID field out of the post object. Similarly, the title field is a GraphQL string that has a description and it gets the title field out of the post. Similar to title, content is also a GraphQL string and that has a description and it gets the content field out of the post. Lastly, we export this object so that we can use this in other files. Now let's go on and implement the query type. Here again, we start by implementing the required types from the GraphQL package. Then we include the post type and post model that we had just defined. Just like post type, GraphQL query type is also a GraphQL object type that has a name, description and fields. Now let us explore the fields in details. The field post is of type post, which means that it returns a post. It has a description, it takes in an ID as an argument, and it returns one particular post from our DB using the post model getPost function. Posts, on the other hand, returns a list of posts object, and it gets all the posts, does not take any arguments, and uses the getPosts function from the model to get all the posts. Lastly, we export this object so that we can use this in other files. Like other types, we start by importing the required functions from the GraphQL package. Then we move on to include the post type and post model we already defined. Mutation like query is a GraphQL object type that has a name, description and fields. Here, our field is createPost, that is of type post, which means that on successful creation of a post, it will return a post object. It takes in two arguments, title and content, both are of type GraphQL string. In resolve, it uses the createPost function of our post model and creates a post. Lastly, we export this object so that we can use this in other files. With this, our implementation is complete. Now we can give it a spin. Let us go and explore this in the browser using the graphical tool. Let us start by creating a post object by using a mutation. As we can see, we can create the post and explore its contents in the same query. We will explore graphical in detail in the next video. Now let us use the query to query all the posts. Here we are able to see the two posts. One is which I just created and one of them which I had created before.